Hi, so this is I think part 3 for component cohesion. So we are going to talk about another principle, that is stable dependency principle. So what it's saying that depend in the direction of stability. So if you create it once your project matures and you divided your software into components, and so then it will going to form a dependency graph, right, like a tree, and it should move toward the stable components, right? So let me give you more example about it. So what it's saying, it is the diversity of software, that a module that you have designed to be easy to change and then can be difficult. Before that, let's talk about stability. What does stable component mean in first place? So stable, if you, the author have given a very easy example to understand. If you like put this penny as a horizontal, like if I am able to balance it somehow, it will, you can going to call it stable, right? but but it is very less stable. On the other scale, if it's resting like in horizontal form, it is more stable, right? So stability means how difficult, how much more energy do you need to make it stable. That is the component of stability. That is the key feature of stability that we are referring here. So it takes about a component, right, a component which have multiple dependency on itself, so it is hard to change that component, right? Because it has to reconcile any changes with all dependent component. Means, what does it mean? Let me show you the diagram. That would be, so this x component, these three other components dependent on depending on x, depending, like using x component, right? Now if I made any changes to x, I have to resync with all three components, right? So changing x is not that easy, so I will call component x as a more stable component, right, compared to all three components, because any change in this component is going to affect all three of component. So you can like form analogy, and if you reverse it, these three component is like less stable. So you can say that the like if a component is used by many other components like as a dependency, then it is more stable, whereas the reverse is also true for unstable component. This component is very unstable because we can change it any number of times, like it will not going to affect anything. So there, now it is talking about the stability metrics, which I am not going to go into the nomenclature or terminology of it, so but I will just give a glimpse of you. So how it is measuring it? So there is a component, right? The number of incoming dependency, that is fanning, it will improve the stability of component, and the number of outgoing dependency that this component uses is going to increase it, that is fan out, is going to increase its making it less stable, right? So it is saying in stability metrics, in stability metrics is going to be fan out, because it is describing by this fan out, like relating to this fan in plus fan out. So if it is closer to 1, your component is more unstable. If it is closer to 0, your component is more stable, and you don't want any of the stream, any of the, and so here he is going to calculate all the instability metrics for each component, but that is like not going to add any much information. But it is also saying, the author is also emphasizing on that, that component should not be stable. Like all components should not be stable. Let's suppose if your program, your application is consist of many components and they are all stable, right? That means that your application is very rigid and it is reluctant to any new changes, right? And you don't want that, right? Because software means constant changes. Seeing that in your mind. So it is saying that the dependency graph should be look like somewhat like this. In stable should be depending on stable. Your dependency always goes towards a stable component. Right, and the last point is, let's suppose you are going to add a new component, flexible, which is like stable components is which for which stable component is dependent on flexible. If there is some changes in flexible component, now it is going to stable component. It is going to impact stable component, and which transitively going to impact the unstable component. So it by adding flexible, by adding dependency from stable to flexible, it is like impacting the stable component, right? Stability of this component. So to, as we have already been discussed 2 to 3 times, that how to solve this like dependency, you have to inverse it. So to inverse dependency, what you use always, there are two ways: independent dependency inversion principle, and the other thing is stable is using something from this component, what you call uh, flexible component. So you will create an interface here in a stable component, and then this will take implementation for, from flexible component will use implementation from this stable component. Now this you are reversing the dependency, and the other way is to create a new component, right? Like common use, whatever common use is there, and now this is depending on this, and even your flexible is depending on this, and it should be also stable component, right? So here I'm going to show you the diagram. So this is what it will be going to look like. U server is a U class, and this is C class. Earlier it was directly depending on C. Now they have created abstract class interface, which both are dependent on. So this is the more stable, and this is also stable because it is a stable component. It is not frequent to change. So now author also introduce a new component. We can call this component as abstract component, because there is no implementation reside in this component. Only the policy level changes, what method you are going to implement or how interface will be going to look like. So these abstract components are very stable, and therefore are ideal target for less stable component to depend upon. So if your component is less stable, it should depend on, because it's very reluctant to change. It's very high, very stable component, right? And yeah, that's it for this principle, the stability principle. Now we are going to talk about stable abstraction principle.